let me tell you a very simple thing for a solid. So you have a solid and you fix it at the bottom and you apply a force which is tangential in nature. This is tangential force, and once you apply the force, you will see the solid starts deforming. Okay, its shape is changing, and you see the angle. Suppose the angle which it makes is alpha, that initial side got displaced or rotated by an angle alpha. Now we are interested to do an analysis how alpha is changing with Ft. Suppose initially you apply a force close to 100 Newton, and for that you get alpha 1 something close to 1 degree. Now on a similar way, if you put F2 equal to 200 Newton, then you see alpha 2 you are getting like 3 degree. On the other hand, if you try to increase the force to 500 Newton, then you will also see like alpha 3 will be close to 5 degree. So ultimately what I am trying to say is that this, when you are applying a tangential force, the angular deformation, which we will get to know later word, that this is what we call as shear strain, that will be increasing. As we increase the force, the alpha will be increasing. Now what happens if you withdraw this force? If you withdraw the force, then what will happen? It will again come back to its initial position. Okay, so what I am trying to mean is that it is almost having what is called a memory. After you withdraw the force, it again comes back to its initial position. Now on the other hand, you see that the deformation that it is happening is static in nature. That means you are applying a force, then at some point of time it is attaining some equilibrium. Okay, then again you are applying the force, it is again attaining some equilibrium at some angle, maybe alpha 2, and in that way it keep on deforming. Okay, and the whole idea is that once you remove the force, it again regains back to its initial position. Okay, maybe something is recovered according to the type of deformation it has gone through, whether it's a plastic deformation or an elastic deformation, but it has some memory to come back to its initial state. Okay, now let us look for a fluid. How does it behave when it is applied with a shear force? Now you have a plate which is fixed, and it is a plate which you can move, and you have a fluid within these two plates, between these two plates, and you apply a shear force or a tangential force to the surface. So then what you observe at first is that the initially maybe this point is B, you will see this point moves to B dash at some time, suppose 1 second. In the expanse of time, you see this point B under the same force, it is reaching B double dash at t equal to 2 seconds, suppose at some later instant of time, and you will see that this point keep on moving from B dash to B double dash to B triple dash to so on. So ultimately what we are saying, the alpha that was in case of a solid, we saw that was more having a static kind of deformation for a solid when you are applying a shear force. But in case of a liquid, what you are seeing, that this alpha is actually a function of time. So as you are applying the force, this fluid is deforming continuously. So this is what we call as a dynamic deformation, which was not there in case of most of the solids, that you will not observe in most of the solid. Okay, and also another thing what we got, like for a solid the deformation was important, but for a fluid, if you see, rather than deformation, the rate of deformation is important. Another thing, that if you withdraw this force, this fluid element which was there between the plate, it will not come back to its initial state. So for a liquid, it doesn't have memory, unlike for a solid it has. So it can withdraw it. When you withdraw the force, it comes back to its initial position. So here we will try to summarize whatever we have learned till now. So if you see for a solid, you see the deformation is static in nature, but in case of a fluid it was more dynamic. And we also saw that due to the application of the tangential force or the shear force, you saw after withdrawing that force, solid is recovering back. That means solid is having a sort of memory. But in case of a fluid, we saw it doesn't have, it is not recovering back while when you are withdrawing the force. Okay, for solid you have free surface, and for liquid you have free surface, but in gases you do not. So this is what we learned in this video. I hope you liked the video. Thank you very much.